to, okay, I'm going to let you vote. This is going to be like a kind of the class decides. So there are two questions here. The one is an analytical geometry. We'll call this A. And this one over here is called question B. Which one would you like to do first? This is paper one. So this is paper one. This is paper two. Which of those two would you like to have a crack at first? All righty. Okay, well then let's go to point A. Okay, so which paper is this in? This is in paper two, and it's what we call the analytical geometry section. It's where we do, it almost feels a bit like functions, except it's on the Cartesian plane, and it deals a lot with shapes and straight lines. And we talk about things like diagonals and sides and quadrilaterals. So to start off today, we are going to try and determine the coordinates of the midpoints of both AC and BD. So AC is the one diagonal of the quadrilateral ABCD, and then BD is the other diagonal. I want in the chat, or I want with your hands, to hear what tool can I use to help me find the midpoints of those two. And I'll give you some time to start working, but I'd love some hints from those who feel like they are aware of what tool to use. Oh, thank you, Mbali and Zanele and Malcolm. We are suggesting the midpoint formula. And the midpoint formula it's given on your answer sheet, so it's worth looking at, but I'll just rewrite it now for you. So to find the midpoint between 2 points, that's the formula we have to use. What I like to do. So I've done AC as an example. You'll notice that I look for the x coordinates of each of these. So 0 and 2, and then I add them together and divide by 2. And so that should give me 1, 0 for the midpoint of AC. I don't know if you got that, but you can let me know in the chat if you agree, but then you need to work out what BD is for me. Then let me know in the chat when you've done that. BD looks a little bit trickier. Okay, so Malcolm has got an answer. Who else has an answer for the midpoint of BD? And Balian's in there. Oh, it's the same as Malcolm, so that's good. Let's see what I get. So I get minus 5 plus 7 is 2. 2 over 2 is 1. And then minus 3 plus 3 is 0, so I get that. Okay, so the interesting thing is the midpoint of AC, Ayanda agrees as well, is the same as the midpoint of BD. And that might be telling us something. So that's good. So 2.1, we've got our answer. Now, what can you deduce about the answers in 2.1? What can you take from 2.1 about the diagonals of a parallelogram? What does it mean if the diagonals have the same midpoint? What's the fancy word? I'll give someone a chance to put their hand up and give me the word. They're almost, they're not equal. The diagonals aren't equal in length in this one. You can see the blue one is longer than the yellow one, but you're close. You're on the right track. It's not that they're parallel. Sometimes you'll see so if you know that this is the middle of this one and it's the middle of this one, often your teacher will do something like this. And what does it mean? It looks like a confused cat, but what does it mean? What do those lines mean about the diagonals? Remember, this point over here is where the two diagonals meet, and it's the midpoint of both of these. The technical term we use is we say the diagonals bisect each other. So what we'll say here as our answer is, let me use it shorthand. So we say the diagonals bisect, and the reason is you have common midpoints. So because you have a common midpoint, it means that it's not that the diagonals are an equal length, because you can clearly see the blue one is much longer than the yellow one, but it's that the diagonals cut each other in half. Now, a lot of students don't understand that they don't have to be equal, but they cut each other in half. Give me a thumbs up if you understand what the diagonals bisect mean, and you understand why, if you have common midpoints, that shows they cut each other in half. Or maybe if there's a question, I'd love to hear a voice explaining the question, or asking the question rather. Okay, no, I'm seeing lots of thumbs up, so maybe I did a good job there. So, okay, if you do have a question, don't be shy to pop your hand up. Otherwise, let's go to the next one. The next question we're going to do is 2.3, and it says you need to calculate the gradients of AC and BD and say what the relationship is between the two lines. So we're no longer using the midpoint formula. We are now using the gradient formula, and I want you to work out the gradient of those two diagonals. And just in case you've forgotten what the formula is for gradient, it is on your formula sheet, but it's expressed like that. So off we go. You can do it. Okay, so I get a gradient of -2 for AC. And if I look at it, that makes sense because it's going in the negative direction. It's going across and to the right and down, I can see. So that makes me happy. Yep. What's the gradient of BD? Okay, so BD, let's make sure I get the right things in the right place. So I'm going to go, it is 7 minus -5. Now, if I start with D, I have to continue with this one. So I go 3 minus -3. Watch out for the double negatives because they actually give you 6/12, which is a half. Okay, so negative minus a minus is a plus. Now, the question is calculate the gradients, but we also have to say what is the relationship between these two lines. So if I observe, they're not the same, so they're not parallel, but can anybody tell me about the relationship between these two diagonals? I'll call them the blue and the yellow. What do we think their relationship is? Oh, I see some good answers coming through in the chat. Don't be afraid to pop your opinion on. So Yanda says perpendicular, and Bali and Zanele say perpendicular. You're absolutely right. Another word for that is at 90 degrees. So what we do is we say, look, AC is perpendicular to BD. And what is the reason? Well, the reason is that if we multiply the gradients of these two, we get -1. And if you can't see that, have a look at this. What's -2? It's -2/1 times a half. And if you do that, the twos are going to cancel and you just have a -1/1, so -1. You don't have to show that, but this is enough here. Okay, give me a thumbs up if you followed the logic there. I'm going to have to clear some space on the screen in a moment, but I think we have done okay. And thumbs down if you're feeling a bit lost, or you can also ask your question. Okay, well then let's move on to the next one. So next one is, hence, so use what has come before this, give the name of the type of parallelogram that ABCD is. Okay, so they're telling you it is a parallelogram, but it's not just a parallelogram, it's a more specific type. If you think of your quadrilateral family tree, who thinks they know what type of quadrilateral this is? Oh, sorry, parallelogram it is. We know the diagonals cut each other in half. We know they meet at 90. What are the possibilities? So it's not going to be a trapezium, because a trapezium is what I call the Table Mountain shape. So a trapezium, to be in the trapezium family, all you need to have is one set of parallel lines. And this shape has two sets of parallel lines. So what are the other types of shapes that we have in the quadrilateral family? If you think about what's possible. Aha. So the two shapes that I was thinking of is the one is a square that's fallen on its side, okay? And that shape is the one possibility. Otherwise, it also could be a kite, but we would have to do more tests to, because we know, well, we know these cut each other. Oh, wait, a kite wouldn't cut each other in half. So, well, yeah, so it's going to be a rhombus. So in this case, we are going to have what type of parallelogram is it? For 2.4, it's going to be a rhombus. And a rhombus is basically if you know that the diagonals bisect at 90, you know that something is a rhombus. So just to confirm, how did we know that that is true? Well, step one, when we used the midpoints, we showed the diagonals cut each other in half or they bisect. And then the gradients helped us know that they bisect at 90. The moment you can prove that diagonals bisect at 90, you know it's a rhombus. Okay. It could be something more than that, but it's at a minimum, it's going to be a rhombus. Okay, so that was a little bit tricky, but let me just go through some tips. If you want to prove something is just a parallelogram, the quickest way to show something is a parallelogram is to show that the diagonals bisect, and you show that by using the common midpoint idea. If you want to show something is a rhombus, you have to show the diagonals bisect at 90. Okay, so that's the quickest way to show it's a rhombus. If you want to show that something is a square, what is the one extra thing you have to add to these? This is actually quite tricky, so I don't want you to stress if you can't get it. It's going to be diagonals bisect at 90, and what else? What's the one other thing that you need to have in order to force something to be a square and not be a rhombus? There's actually two things it could be. Yeah, so all the sides are equal in rhombus and square. But what's different in a rhombus, and if you look at this, is can you see the diagonals are of an unequal length? So what would force a rhombus to be a square would be if you have equal diagonals bisect at 90. So the moment you have equal diagonals, then that would force it to be a square. Okay, or if you're at a corner angle of 90. But anyway, I'm getting distracted by stuff that's not as important as what's here. So let's get back to the main question. I want you to find me the equation of AB. So find the equation of the line AB, which is on this thing here, while I clear this up. I just mustn't forget which one, -2.5, the gradients and the points and stuff. So A is the point 0.2 and B is the point -5, -3. So can you find me the equation of the line, which we know is going to be in that format? So if we think about AB, the first thing I have to do is work out the gradient, because that's going to be the M. But and then I can sub the point 0.2 in to get what C is. So it's going to be y equals x plus 2, or y equals 1x plus 2 for 2.5. Okay, next step, unless there are any questions, is find the value of k, the x-intercept of the line AB. So they want to know what is this blue point over here, and you need to use the equation of the line to help you. So what is the x-intercept there going to be? How do we find the x-intercepts? So I was thinking it's going to have to be x is minus 2 is the x-intercept. And if I look at k, so the point h is going to have to be the point minus 2, 0. Give me a thumbs up if you understand how I got the value of k. And then the value of k is just this thing here. It's, it's the x-intercept of that one. Give me a thumbs up. Give me a thumbs down if I've lost you. Okay. Keep those thumbs coming. Don't be afraid to use your thumbs or your virtual thumbs. Then the next thing we have to do is, now that we've got that one, is 2.7. So 2.7, find the magnitude of BAC. So let's find BAC. 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 Okay, this is a bit tricky. It's that angle up there, isn't it? Okay, I'm going to help you a little bit with this one. If you think about finding that angle up there, I think that it's possible to find this angle, and it's possible to find that angle, and though the blue and the green one will help you find the red. What theorem connects up the blue, the green, and the red angles? What theorem is going to connect up those angles? I was thinking that it is the exterior angle of the triangle theorem, right? So we know that the blue one must be equal to the green one plus the red one. But and it's the exterior angle of a triangle equals the interior opposites. But now I need to find what the green and the blue angles are. What formula, if you think back to the last lesson, am I going to use to find these angles? What do I need? This is important. Which formula am I going to use here? Yep, the formula I'm going to use is tan of theta equals m. And I have, from earlier in the question, tell me if I'm wrong, but I'm pretty sure that AB's gradient is 1 and AC's gradient is -2. So I want you to tell me, what do you work out the green angle is, and what do you work out the blue angle is? I'll give you some time for that, and then we'll have a talk. Now, you're doing this is a proper exam question here. So you ride up to the level. So if you are feeling a bit shaky, don't worry, you can rewatch this. But we really are at proper exam level questions here. Oh, you know what? You're right. We could have actually used Morgan says, can we use the right angle? So the right angle, Morgan, was with this going like that. You possibly could use the right angle, but I think probably it's quicker to do this way. But it's not impossible. Maybe the right angle could be used as well. Yeah. But I'm going to stick with this one for now. So I think the green one is probably the easier one because it's a positive number. So we get tan of theta is 1. And what's my theta going to be for the green one? So we go shift tan 1, and you should get 45 degrees. And so you now know that that is 45 degrees. But we have to find the blue one as well. Now with that one, we have a choice. There's two different ways of doing it. The one is to ignore the negative and then know what quadrant it's in. Or if you leave the negative in, you normally have to add 180. So what do we get for that angle? And if you look at it visually, you can see it's greater than 90. So this angle here is bigger than 90. If you get an angle smaller than 90, you need to do something to it. Who's got some blue answers for me? So Mbali and Zanele have locked in their answer. Who else has an answer? I want to see that you confirm. Before I get my calculator out. Oh, it's windy outside. I get 116.57. And the reason I got that is initially I actually got minus 63.43, but then I added 180 to get this bit here. So this is going to be 116.57. I want to know now, to finish this question, what is the angle, the red angle BAC equal to? Using what you know about the exterior angle of a triangle. And then it's time for an exercise break. So we know that red plus green must be equal to blue. So we know that green was 45. I'll even put the reason here. Exterior angle triangle. So we know that's 45. We know this is 116.57. How are we going to get the red one? We can even call red X if we like. How are we going to get an answer for X by itself? or BAC. Let's make it BAC instead of X. BAC was what they asked for. Minus 45. What is my final answer for BAC? I think I just take away 45 from both sides. Yeah, I agree, Malcolm. You're on the same page as me. Because if you take away 45, Brooklyn, same thing. If you take away 45 from both sides, you're going to get 71.57 degrees. Now, that is a question that most students would not get correct. So if you've understood that, well done on you, because it was a whole process that we had to go through. Now, we'll come back after the break to 2.8, but for the moment, I want us to stand up and just relax for a bit, because if you try and do too much, then your body starts to go, sorry, I'm not going to remember this. And we do want you to remember stuff. So stand up, get some space near where that you don't, I'm not going to knock anything over. And then let's just breathe. Okay, so I hope you feel like you've got some oxygen. I want you to shake your arms around, like they're nice and loose and floppy. See if you can get them going in a circle, and then wobbling like this. And then I want you to roll your shoulders, roll them back, roll them forward. And let's do an arm stretch like this. And do an arm stretch like this. And then shake it out one more time. Shake out the legs. Okay, and then last thing, let's just do some air skipping. We're going to do 20 air skips starting in 3, 2, 1. Let's go. 5 more. And we are done. Okay. Let me know in the chat if your body feels a bit more relaxed. Or let me know in the chat if your body doesn't feel more relaxed and you feel irritated. I don't know. I'm always curious to know what students are feeling on the other side. Okay. And then while we are just letting our heart rates come down, here is a Maths 24 question. You know how this works. Can you make 24 using the numbers? That's a 9 in the red. Yeah, I always like that feeling of your body breathing, and then that pumping heart feeling also is nice. It feels like it resets my concentration. Who can make 24? Who wants the glory for the last Maths 24 question of the year? Nine, 1, 8, 7. So 9 plus 8 plus 7 is 17 plus 24. Oh, but then if you take all those and divide by 1, You have 24. So Ayanda and Mbali, I think Ayanda just got there first, but you have got the red ones done. What about the blue one? This is a 6. Who can make a 6, a 5, a 3, a 1? 6, 3. I'm finding the blue one hard. Although I must probably move on now, but anybody got a final idea on this one? That is a 6, yeah. Okay, we'll come back to that one if we can later in the lesson, but that seems to have got us stumped for now. Oh, wait, has someone got it? Tando, 6 times 3 is 18. Oh my goodness, it just shows you 6 times 3 is 18. And then 18 plus 5 plus 1 is 24. So well done to Tando and Mbali and Zanele. You were winning at life with that one. Okay, well, let's finish off with the question we were doing. So the last question from this past paper question is, in triangle ABC, determine the equation of the line from C perpendicular to AB. Okay, now what does that mean? The line from C perpendicular to AB. Now, perpendicular to AB would mean basically it hits here at, well, it doesn't have to go through that point, actually. It can go through anywhere. So if it was going to be at 90 degrees, if you imagine a line that goes through the point C, but is perpendicular to this line AB, they want you to find the equation of that line. Okay. Now, if you want to find the equation of any line, you need to know its gradient and you need a point on the line. So as we look at trying to find the equation of this blue line, which let me make it solid. We were trying to find what the equation of that line is. Who has some ideas for how I would find M? How am I going to find the gradient of this blue line? What information in the question could help me find the gradient of M? Now, I do think earlier on I worked out the gradient of AB, and the gradient of AB was 1. Who has some ideas about how we can find the gradient? We'll call it, I don't know, the gradient of the perpendicular line. Well, if lines are perpendicular, when you multiply the gradients together, you have to get -1. So we know the gradient of AB times the gradient of the perpendicular must be -1. We know that's 1 there. So the only way this could work is if the gradient of this was -1. So now we know that the equation of the straight line is -1x plus c, but we need to use a point on the line. And the point on the line is 2 minus 2. So I want you to work out what is my final straight line equation. Hmm. I need to figure out what C is. Now, that's going to be a 2, and that's going to be a C. And then when I bring the -2, that's going to become +2. So C is going to be 0. And so the final answer is going to be y equals -x or -1x plus 0. But we don't normally write the 0. So your final answer is the equation of that blue line is y equals -x. And it's actually going through the origin. Give me a thumbs up if you got that. Give me a thumbs down if you didn't. A bit of a tough question, that one as well. Okay. Cool. So what I'm going to do now, grade 11s, is I am just going to do some admin with you before we finish off. I think we did that question quite nicely. And so I just want to do some admin. And also, we'll put the quiz link up in a moment. So let me get a spare page. So everyone, I don't know, this email is going to go out to your parents tonight, but next year, Watobe is going to be kind of taking on a new form. The existing business structure won't exist next year, but the existing teachers that are teachers at Watobe will be offering extra maths under a new banner, basically under a new brand. And so your parents will be getting communication about that this evening. But I just wanted to let you know that we will start with classes again next year on January 8th. And so for those who would like to be part of that continued extra maths online lessons, you need to fill in the form that your parents are going to get probably in the next day or two. And so what that is it's an expression of interest in the service that the teachers who are part of Watobe will be offering. We're offering the same classes that we did this year. So for example, I'm going to continue to take grade 11 and Miss Lee is going to continue to take grade 12. But I just wanted to let you know about that because I know now you're almost finished exams and quite quickly now the school year finishes off. But I just wanted to let you know that even though Watobe is changing and the brand Watobe won't be there, us as teachers will be continuing. So I don't know, are there any questions or comments about that? I also want to say thank you for the year. Like, I've really enjoyed teaching this group. I know today it's a much smaller group, but like, yeah, it's been a lot of fun teaching. I do hope that it's been helpful for you. I don't know exactly, yeah, like I'm curious to know how it felt for you, but I really enjoyed it. And so I do wish you the best for your exams. And I just thought we'd take a minute or two now to have any questions for students or any comments from students. Just Kia, thank you to you. Thank you for your help. It's been impossible to run this group without someone helping in the chat. And yeah. So are there any questions or comments, everyone, before we post the link for the chat? I do wish you a great holiday once you get past your exams. Don't give up now. Keep pushing. But yeah. So Keisha, what I'm going to suggest for statistics is you go and have a look at the past. Oh, wow. Increased by 20%. Ayanda, that's amazing. Sure. And how long, Ayanda, have you been with Watobe? I'm trying to think because it feels like only a couple of months. Okay, let me have a quick look. First year, yeah. Yeah. No, that's impressive, hey? Sure. But obviously you were putting in a lot of hard work too. So for those who need help with other topics still, wow, level 2 to level 5. Yeah. And the thing is, it's often about students getting motivated. Hey, like I think that's what I see my role as, is giving people hope in maths. And then once you get motivated, your own energy kind of takes over. So the only way you go from level 2 to level 5 is if you've been practicing a lot. So congratulations. Wow. That is epic. So Ayanda, this is the last lesson for the year, but what I want to show you is as you look for more lessons, every single lesson I've taught over the last 2 years is on the website. So let's just have a look at where you find your lessons. So if you go to the website, you click classes and you click grade and you click grade 11, you will notice that there are lessons on every single topic going back for the last 2 years. So if you click on statistics, for example, or if you click on another heading, it will drop down into the specific lesson titles, and then you can go to that particular lesson that you need help with. And especially at the end now, if you feel like you're weak in a particular area, I would highly recommend going to look at these topics for extra top-ups. All right. Kia, is there anything you want to say to the students before we wrap up our thing?
I was actually typing a message in the chat thinking maybe I
Okay.
won't get some screen time. But I just want to say that I've enjoyed working with each and every one of you. It has been amazing coming to these classes and helping where I can. And I'm also proud of the students that have been joining us every single Monday and
Yeah.
Wednesday. Hey, it takes a lot of commitment. And I see
Yeah.
in the chats that some of you are really improving in your maths, and it's really amazing. And I hope that you will take the opportunity to continue studying with the
Yeah.
teachers of Watobe. So
Yeah.
I just want to say I'm very proud of everyone and I'm happy to have
Yeah.
met you all.
Yeah, you definitely get a feeling of pride because I know it does take hard work and we're genuinely doing something quite unique here. And I think in that sense, you guys are pioneers, like it feels like being a pioneer myself, figuring out how to do this. And yeah, one of the questions in the chat is about the website changing. So I do want to show you the YouTube channel as well. So let me just take a moment to just show a the YouTube channel for Watobe in case you want to look up other stuff. So Watobe YouTube. And if you go to the website, let's just find it. And here are all the lovely teachers of Watobe. And then if we go to playlists and we go to foundation, and then you can see all sorts of lesson topics here. And you can look up, say, for example, you want statistics, right? Let's have a look here if we can find some. Okay, this is all the revision stuff recently. There's functions, probability, analytical geometry, trig, statistics. Here we go. So stats, and you can find lots of stats foundation, histograms, and frequency polygons. So don't be afraid to look things up on the YouTube YouTube site, is what I want to say to you.